network design. To some people, they will be wondering, why do we need to talk about network design? What is the big deal in building a network? Is it not just to drop switch and then start configuring? Or if you don't want to configure, you just drop a switch and then you link computers to the switch and that's all. That won't be a problem for a small network where you have to use just one switch or two switches. But the moment you start having a big network of maybe 300 computers, 400 computers, and so on and so forth, that is where there will be a problem. So this design is very important because if you don't understand this and you happen to work on a big network, work in the sense that you are the one to build network, there's going to be a problem. So that's why I want to talk about network design. It's one of these chapters I could have left for you guys to read on your own, but I have some things I want to point to that I need to emphasize. I need to emphasize some things in this particular chapter. So what are the things we need to talk about? We're going to talk about hierarchical network. We'll talk about scalable networks. We'll talk about switch hardware. And we're also going to talk about router hardware. So let's start with hierarchical network. So basically, we're going to be
Sir, please
explaining.
recording, sir.
Yeah, you say?
Recording, sir. Recording.
I have started, yeah.
Okay, sir.
So basically, we're going to be talking about network design. And these are all the things we're going to explain under network design. But in particular, the first thing we're going to talk about, which is the hierarchical network. Now, I want to say something here. I said if for some people they'll be like, what's the big deal in building a network? It's not just to drop a switch. Then you link computers to the switch. And if you need internet connection or you want to segment your network, you bring in a router. Excuse me. Sorry about that. I went somewhere yesterday and the weather was very cold and I forgot to package myself the way I used to package myself. So cold entered me.
Sorry,
Hard
sir.
luck about that, sir.
Thank you. In fact, I was like, this weather will change before I get to where I'm going to. Unfortunately, the weather no change. It started raining. So the cold, before I got back home, I caught cold, serious cold. Okay, so you just feel like, is it not just to drop a switch? Add computer to the switch. Maybe this is PC A, PC B, PC C, PC D. And if you need internet connection, get a router and put access, connect to the ISP. For a small network, this is not a problem. When I say a small network, for instance, if the people on this network are just, let's say, 20 users, it's just to buy a 24 port switch. That will solve your problem. If the people on this network are like, let's say 40, it's just to buy 48 port switch, that will solve your problem. Or you buy two switches and cascade them together, link them together, put some guys here and some on the other side. That will also solve your problem. But the moment you begin to talk about 3 switches, 4 switches, 5 switches, 8 switches, 10 switches, because most of the switches you see around, they are just 24 ports. So what if you now want to network computers with, let's say, you want to build a network of 200 computers, or let's say 270 computers, like most of the CBT center they used to write JAMB. You know that one switch cannot take care of your needs, cannot solve your problem. So you're going to need minimum of 12 switches. And if you are going to deploy 12 switches on your network and you don't know about what we want to talk about right now, you are going to be in a mess. NANLAC is like you did not rewrite your CCNA1 exam and you didn't bother asking me that you want to rewrite, and your score is not good. That's the person that just came in now. I hope I pronounce his name well. And you're always in the class. You don't used to miss class. So you're supposed to be able to do to take another slot, the second chance, and do it well. So please do something about it. So once you are beginning to have a LAN of the size of CBT center, where you have 270 computers, 300 computers, 400 computers, you are going to be in trouble. Now, one of the reasons why I'm putting emphasis on this is because I didn't know this before until when JAMB started doing CBT, the first CBT they did in the country. So I got a call from one of the centers that they need help because things were not working correctly. So I couldn't help because I was busy that period. So I gave them a friend's number. Then the guy went there to check what the problem was, and he was able to troubleshoot. And then I called him later and said, so what was their problem? Then the guy now told me that they cascaded their switches. I said, what do you mean by they cascaded the switches? So when we talk about cascading the switches, let's assume you want to network, let's say 200 computers. So you know that you need like 10 switches, right? So you carry switch 1, to connect to switch 2, connect to switch 3, connect to switch 4, connect to switch 5, then switch 6, like that. So some people will be on this switch, some 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 will be on this switch, until you get all the 200 people. And probably the server will be on one of the switches. That is the server that the JAMB guys used to use. So this is what they did in that particular place, and most of the centers nationwide. This was what they did back then. And if you recall, you will realize that the first CBT CBT exams was a mess all over the country. So I said, so what's the problem with that? So he said they cascaded. I said, so say, don't I know about the hierarchical design or the network design? It's not going to work now. They are going to have problem now. Since that day, whenever I'm teaching this particular chapter or talking about network design, I make reference to the JAMB, the CBT centers design, and then emphasize on this: the need for you to follow a good network design whenever you have more than at least 2 switches on your network. So that's what I'm doing here. That's why I'm talking about things like this. Okay, so I'm going to show you the right way to do it. So let's start the journey. They need to scale the network. Anytime you talk about scaling the network, we're talking about growth. So when you hear that the network is not scalable, you simply mean the network cannot grow. So, and whenever you are building a network, you must build the network in such a way that it can grow. What do I mean by that? Tomorrow, you can add more switches. You can add more switches. You can add more switches to extend the network, and there will be no problem with the original design. But if you build your network in such a way that anytime you want to expand or you want to grow, you have to scatter everything before you can expand, that means that network cannot grow. That means the network is not scalable. So you must build a scalable network. So organizations increasingly rely on their network infrastructure to provide mission critical services. We all know that. Because it is the infrastructure we build that will carry our voice, that will carry data and also carry video, voice, data, and video. So when you want to build a network, you don't just factor in a data network, you also factor in voice network. You also factor in, or let me say, voice traffic, and you also factor in video traffic. Because some of the times, or if not most of the times, the client don't even know what they need. So if today now the client say, well, we just have 20 computers on our network, just build a network of 20 computers. By the time you go and buy a 24-port switch and you don't give room for growth, tomorrow they will come on, we have decided to expand, or we have another office, or a new department, so we have added 5 computers, then you are hooked, you are stuck. So sometimes they don't know what they need. So when you are building the network, when you are designing the network, you must factor in growth, which is what is called scalability. And part of the growth is, if what they are requesting for now is just a data network, just to send data. What I mean by data is maybe just to browse the internet and majorly just give us internet access. They are not talking about carrying voice on their network. They are not talking about carrying video on their network. You have to factor in all of these things. And if they have money, you make sure that you build a network that can support data, voice, and video. All of them. So tomorrow if they call you, you have already taken care of that. So the network you are building must be able to scale, and it must support all of this. Number one, a converged network traffic. When they talk about converged network traffic, we're talking about data, voice, and video. Critical applications. What are the servers they have on the network locally? What are the things running on those servers? You must build a network that will support the application. Not that the users on the network want to access the application on the server and it's taking forever. When you are within your network locally, the speed at the rate at which you access the server should be wonderful, that people know that this thing is seated with you here. Diverse business needs. It does not matter what you throw at your network, it should be able to handle the traffic and centralized administrative control. So that we can explain it in different angles. So you must be able to control the network. You must have visibility on the network. So now look at this now. Campus network design includes small networks that uses a single LAN switch, up to very large network with thousands of connections. Now, in one of the classes, I remember talking about campus network. Campus network is just a network that has plenty computers, plenty connections, like maybe in there thousands, 1,000, 2,000, and so on and so forth. Okay? So when we talk about campus network, we must have a design. And our design must be scalable and must support all of these things we have talked about in this place. Now, we are going to the design gradually. We are going to get to the one that are very important to us in this class. Borderless switch network. The Cisco borderless network is a network that can connect anyone, anywhere, anytime, on any device, securely, reliably, and seamlessly. So if I'm building a network for any organization, I should be able to build a borderless network. So what is a borderless network? That's what they just explained there. You can connect anywhere. You can connect anytime. You can connect anybody. You can connect with any device, and you are connected securely, reliably, and seamlessly without stress. And the key to building a borderless switch network, or the key to build scalable and reliable network, the key, major key, is design. I told you guys I didn't know the importance of design until that time when JAM started CBT centers in the country, and I didn't even finish the story. So when my friend solved that problem, so he just redesigned the network, he rearranged the switches and the connection between the switches, and recreamed the cables that were not properly crimped, and that was it. That was the end. So I have a friend that was pursuing a JAM contract. I think it was following year to build a CBT center for somebody, for a particular somebody that was trying to set up a CBT center. So the guy came to my house that he wants to do this because he doesn't really know about networking. Because of my experience previous year, I said, come, let me show you the secret to this thing. So the guy came to my house. I just drew on paper. You drop a switch. I'm going to show you guys what I did. And you drop another switch and so on and so forth. I explained the whole thing to him. After the guy finished the first contract, that's how people started calling him. He set up, only God know how many CBT center he set up in the country. Because they are always making reference. People say, but these particular centers, they are not having problem now. They are doing well. Everything is working fine. And I was the one that gave him just the design. And that was what solved problem. So I got to know that later on, even JAM themselves now understood the problem. They got to know the problem. So they got the design from somebody and they now publish it. Kind of anybody that want to be, you want to have a center, they'll give you the design. That whoever is building your network should follow this design. And that solves everybody's problem. So nationwide now, building CBT center is not a challenge as long as the systems are not having problem. But the network is going to be able to handle whatever is thrown at it. Okay, so for a borderless network, this is what we will get from a borderless network. Now, it provides the framework, that is the borderless switch network now, to unify wired and wireless access, built on hierarchical infrastructure. What is hierarchical infrastructure or hierarchical design? We're going to talk about it now. That is scalable and resilient. Now watch this. Watch this. Borderless switch network are hierarchical. That's key. Modular. That's another key. Resilience and flexible. The main thing I want to talk about here now is hierarchical and modular, but especially this hierarchical. So when you hear that word hierarchical, what does that mean? What does that mean? So this is now the key now. Hierarchy in the borderless switch network. Hierarchy in the borderless switch network. Hierarchical network used a tier design of access, distribution, and core layer, with each layer performing a well-defined role in the campus network. So when we want to follow this design, hierarchical design they are talking about, we have two. We have 3-tier layer. We have 2-tier layer. So what is the meaning of all of these things? They're simply telling us for you to build a network that is scalable, that is resilient, that is reliable, and all of that, you must follow this design. So what is in this design? If you want to build a design, if you want to follow 3-tier design, what is in the design? Look at our users here. And of course, we have IP phones also that are connected here. This is my switch. These are the switches. I have switches on this network, in this design. Then I have another set of switches. Look at them. I have 4 switches here. And then I have 2 routers. And I have 2 different service providers. So what they are simply telling me now is for me to build a scalable network, a reliable network, a resilient network, this is my best option. How do we simplify this? I'm going to come to that. Now, this is what we are trying to say. So it simply means now, if I want to do what is in this place now, for instance, now let's say I'm looking for a contract now. Now, if I give you a proposal to buy 2 routers, to buy 4 layer 3 switches, and of course the layer 2 switches depends on the numbers of users on the network. So I am giving you quotation for 2 of everything, or multiply by 4. Why am I doing that? Because I factored in what we call what is it called? I factor in redundancy. Redundancy in one sense. This is what I mean. If anything should happen to this router, this service provider is done. That doesn't mean that the service provider is done. As in, if my router should die, there's no access through that router. So the other router is still working. Also with the switch, if anything should happen to this switch, this other switch can still be used to reach this router because you can see the connection between the two of them. Let me show you the connection. Look at the connection. Let's assume this guy is trying to send something or he's trying to go to the internet. He can decide to start the journey and pass through this switch. He can pass through this link, go straight, go through this router and go to the internet. And you can also pass straight. If there's no road on the between this my layer 3 switch and the router, you can cross like this, go to the internet. So I don't just have one path to go to the internet. I have multiple paths as a user on the network. So we have multiple connections. And this is your best design. If the people you want to work for can afford to buy all these devices. So if I can go straight, I can go cross border, continue the journey. I can go straight, cross border, continue the journey. It doesn't matter. There's all kinds of redundancy built into the design. And this is your best option. So, but sometimes, or let me say, most of the time, this is not feasible. Because if you get a contract and you give somebody quotation to buy all of these things, and another person is giving quotation to buy just single device, because we can as well do this thing by dropping a switch. This is just one switch, connect it to the router, and connect it to one ISP. And there are users here. We'll still get the same job done. But this is called a single point of failure. A single point of failure. So now, why do I need all these switches that are in between here? For a big network, like campus network, universities, where you have 15,000 users, and so on and so forth, you are going to have multiple buildings connected together, connected to the, let's say, to the server room and all of that. I'm going to show you how I will give you a simple design before we now relate it to this complicated one. This is going to be your best option. And if you're able to follow this design, you are good to go. But if you don't really have money, you can go to the second one, which is called 2-tier. What is in the 2-tier? Instead of having 4 layer 3 switches, we can just deploy layer 2 switches and follow this design. Look at it from this switch here. There's a cable connection to all the switches, the layer 2 switches. From this switch here, there's a connection to all the switches. And this one connected to the router, and this one connected to the router, and this router connected to the internet. Now look at, something I didn't explain here, sorry. This router has 2 legs to different service providers. One leg here, one leg there. This other router has 2 legs, one leg here, one leg there. So either way, we're always going to have connection. So now look at here. So we eliminated 2 switches. So this one here is called 2-tier layer. And this one here is called 3-tier layer. I'm going to bring it home. Let's just continue. So if I want to build like for maybe an organization, they are not that big, like let's say 1,000, 2,000. There may be a need for me to drop these two multi-layer switches. But if I have an environment like in university where I have 20,000 users, definitely this will be my best design, my best option. And I will bring it up for you guys. Let's just move on. Now, here, where we are here, this place is broken down into 3 layers. Please, this is not OSI model. This is not OSI model now. The layers where you have the routers is what we call core layer. The layer where you have this layer 3 switches is what we call distribution layer. You can see it visible here. I didn't even know. I can see, now I can see them here. So this is our core layer, this distribution layer, and this is our access layer. Access layer is where you have all the switches that are connected directly to computers or access points or IP telephones. So now they are now trying to explain what happens at each of these layers. Now, this is not OSI model. It has nothing to do with, we're not talking about OSI model here or TCP/IP model. That is just a framework for setting up this design. So now they are now trying to explain it here to us. So since we know that in that design we have 3 layers, so what happens at the access layer? The access layer provides network access to users. So anywhere we have where we can plug directly to the device, whether through wired or wireless, that's our access layer. You see, we are not plugging directly to the routers. We are not plugging directly to the layer 3 switches, where we are plugging directly to the layer 2 switches. Access layer switches connect to distribution layer switches, and I showed you that before. So what do we have at the distribution layer? Look at what happened at the distribution layer. The distribution layer implements routing. We have talked about routing before. Quality of service. What's quality of service? You prioritize traffic and security. So it therefore means in my configuration, it's not just about the physical design. When I want to begin to enforce or implement policies, anything that has to do with routing and that has to do with quality of service and that has to do with security, I do those things at the distribution layer. So it also aggregate large-scale wiring closed networks and limit layer 2 broadcast domain. What does that mean? When there is broadcast coming from our layer 2 switches, they don't cross they don't cross this place, because from this switch here to this other switch here is a layer 3 connection. From this switch to this switch here, layer 3 connection. All these switches here, they are all layer 3 connection. But from here to the layer 2 switch is not a layer 3 connection. And therefore means if there is a broadcast on any segment, once it gets to this switch is more or less like a router on the network, please. You see that switch, layer 3 switch, is doing the same thing like a router is doing. So what about the core layer? Okay, distribution layer connects to access layer and core layer switches. So it's our distribution layer that is sitting in between the access and the core layer. So what happens at the core layer? The core layer is a backbone and connects several layers of the network. Now the core layer provides fault isolation and high-speed backbone connectivity. Now it's not only core layer that is providing fault isolation, meaning if there's a problem, it's only particular to a particular that side of the router. Other side of the routers are still working. Even if the router dies, the other router will still be working, and that also happens at the distribution layer also. So they are giving us an example here. The 3-tier campus network is used by organizations requiring access, distribution, and core layer. Now look at this now. The recommendation is to build an extended star physical network topology from a central building location to other buildings on the same campus. What is the meaning of that? I will explain from my drawing. I'm coming to that very soon. 2-tier campus network. It is used when separate distribution and core layer is not required, meaning we don't need separate distribution. I will also explain that better. It's useful for smaller campus location and in campus site consisting of a single building. And it's also known as collapse core. So when you hear collapse core, we are referring to the 2-tier. Collapse core, we are referring to the 2-tier. So let me explain some things. I think I need a blank paper here. Can I get one? I need a space. I don't want to remove this my PowerPoint because it's always freezing if I try to touch anything there. So you allow me to unshare this. Maybe let me launch another PowerPoint. Let me see if there's any place. Okay, this place should be enough for me now. This place should be enough for me. Let me just use this space here to draw. Now, let me give you an example. Let's assume we have, which one do we start with? I will make simple one, direct, without backup, but just a good design. Okay, let's start from that CBT center first. So, what did I advise the guy to do? I said, okay, you have how many switches? Let's say you have 12 switches. And those 12 switches, you want to link them up to computers directly. So I say, get one of the switches, make it a powerful switch. When I say a powerful switch, I'm talking about maybe the speed. It should be a gigabit. Even though nowadays we have gigabits everywhere. Then this switch, let's say it has 24 ports. So you can now connect other switches to this switch. These are switches. So these are switches. So if I connect, let's say 10 switches to this particular switch, on each of these switches here, let's say 20 computers can connect. 20 PC, 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 until you get the numbers you're looking for. So if this switch is 24 port, that means you can connect 24 switches to this particular switch. So all the switches that are in this place, if you like, they can be gigabits. If you like, they can be 100 Mbps, not a spot for CBT center. So I say, but this one that is here, make sure it has enough speed, minimum 1 gig on each of the ports. So what do you do with the jam server? Plug the jam server on one of the ports here. Let's say this is the jam server. So when people want to access the question on the server, so the computers on this particular switch, they all only go through this one switch and get there. People on this switch, they go through one switch and get there. People on this switch, they go through one switch and get there. The same thing applies. So it's more or less like you have only one switch on the road before you get to the destination. With that, there will be no problem. But the moment you cascade your switches, like this, and you now put your server on one end of the switches, guess what is going to happen? If there are 20 people on this switch, they are traveling to the way to the server. So on this link, there are 20 people. On this switch, there are people too. By the time they join the journey, on this link, they will become 40. By the time these people on this switch also are trying to go and reach the server, all of them join together here, they become 60. By the time these other guys or set of people on this other switch are also joined together, on the link here, they become 80. Before you know it, they create bottleneck on that link. And this is a bad design. In fact, somebody call it the beginning of death, chain connection. So you don't design your network by cascading switches. This is what you do when you have a big network. And when I say big network, you can decide to do something like this for a network on, let's just say 300. As long as you are going to use more than 2 switches, you just have to follow this kind of design. And that, you are not going to have a problem. Before we now take it further, let me give room for questions.
Hello, sir.
Yes, please go ahead.
So this cascading that you mentioned, does it mean that connecting one switch to another switch to another switch?
Yeah, that's what I mean by cascading. Yeah.
Okay, sir.
Yeah, chain connection. Chain. Just straight line.
Okay, sir. Thank you, sir.
Any other question?
Question, sir.
Good evening, sir.
Well, sir, I want to ask, are you permitted to make any configuration the same way you do in the distribution?
Yeah, what you're going to do, you see?
You're talking about.
Okay, let me just put it this way to you, sir.
Hello, can you hear me, sir?
I can hear you, sir. Let me put it to you, sir.
Okay.
For environment where you have like these CBT centers, you can decide to just do plug and play. Like this person I'm talking about, he does not need to buy configurable switches, just plug and play switches. But in an environment where you want to make decisions, you want to configure VLAN, you want to be able to manage the devices and all of that, you need to do configuration. But I'm just talking of simple environment where you don't want to do any configuration. You don't even know about configuration as such. You just know how to build basic simple network and drop a DHCP server to give computer IP addresses. That's what I'm saying now. And my best case study here is the CBT centers.
Okay.
So you can just do plug and play, plug your computers, drop the
Okay.
server somewhere, and you're good to go. But you won't be able to manage the switches because they are being used as plug and play. But we cannot do that. With our level, we are going to be in need of managed switches, devices that can be configured because you want to do VLAN, you want to do enforce policy, implement policies, you want to do routing, you want to do all kinds of stuff. So all those configurations we have been learning before, you are now going to bring the skill here. So this is just about the design, the placement of the devices, and the way they are connected together. We are like architects now.
Okay. Thank you.
Any other question, please?
Okay.
Yep. Question? Okay. So if we don't have question, I'm going to continue. So this is just what I gave to that guy.
Okay. Thank you. Thank you, sir.
You're welcome, sir. This design I gave to you people was what I gave to the guy, and he went and built the first CBT Jam CBT center. Before you know it, he got another contract to build another center. He became a guru. People announced they were now seeing him like expert because of just because of this design. But most of these other centers at the initial stage, what they were doing, they were just cascading switches nationwide. Most of the centers, the engineers are, of course, they will give the contract to people that don't even know what they are doing. I'm talking of the CBT centers, well. So, and unfortunately, the JAMS engineer too, they call them network engineer, they don't know too. In Nigeria, you put a round peg in a square hole or the other way around. They don't know too. How do you get a jam engineer that it doesn't have CCNA, even if it is fake CCNA? They should have it. So that was just so now I want to take it further. Beyond what I just showed you guys, or explain now what I drew for you people right now. What will if we have a scenario where we have multiple buildings, and in each of these buildings, or in each of the buildings, yes, you have like 200 users. That means we need multiple switches in each of the buildings. So let's say we have 10 buildings, and each of the buildings there are almost 200 staffs, and we have our server room somewhere. What are we going to do? This is another design. Still following the hierarchical design, but I have not brought in, I'm here to bring in redundancy. So I can have my router connected to the ISP, which is the internet. Then the connection from this router comes to a layer 3 switch, a multi-layer switch that has, let's say, maybe I'm going to be connecting to, let's say, 10 buildings. So I need at least 10 ports on this particular switch here. So I'm going to have a connection going to one of the buildings, another connection going to another building, like that to each of the buildings. But I know that in this building where I am going to drop this connection here, I'm going to have 20 switches here. So this particular switch where I'm dropping my connection is also going to be a layer 3 switch. I mean a layer 3 switch, yeah. So this probably has 24 ports. So each of my connection will go to different switches in that building. Different switches in that building. Now this is just to take care of one building, though. And I will replicate this in another building. This another switch, another layer 3 switch in another building. And this particular switch is a multi-layer switch also that will serve other small switches like that. Now, this is the idea. This capacity of this switch must be way bigger than this one. It must be more than this and this one, because you are going to be having aggregation of traffic passing through this guy here. So that will happen to the third building, to the fourth building, to the fourth, and so on and so forth. So in each of the buildings, you realize that you have a multi-layer switch that is taking care of the switches that are serving people in that building. So of course, the connection between these two switches most of the time is always a fiber connection. Fiber. And from this switch to this other, most of the time is your regular UTP cable or STP cable. And if you have money, you can also make it a fiber connection to all the switches. This is another design. So you see, there is no straight jacket. It all depends on the environment you are in and if the people have the money. So if they have money, I can decide to say, okay, we can now make this into high SP. We can make these switches here, 2 switches. And then even the one in the buildings, they can be 2. Then we can now begin to follow all those connections you saw earlier. This connection you saw here. Where is it? This connection you saw here. So if they have enough money, you can decide to adopt this. If they don't have enough money, you can decide to adopt this. Just make sure you have a level of redundancy. And sometimes this is not because whether they have money or not, because you are dealing with big organization. Big organization. Like I just explained now, where you have these core layer switches, and in each of the buildings you have one core layer switches. And this core layer switches is connected to multiple layer 2 switches, and this one too in another building, multiple layer 2 switches. It depends on it's flexible. Just understand what you are doing. Once you understand what you are doing, this is flexible. But whichever way you cannot cascade, you must always have a hierarchical design to take care of your need. Small or big, you must always have a hierarchical design. Is it clear? Am I complicating, please? Steven, are you okay? Hello, Steven, are you talking?
No, sir.
Okay. Yeah.
Hello, sir.
Yeah, please go ahead.
Okay. I think the description you just gave now. If you are to advise,
yes, sir,
for cost and efficiency, which one takes preeminence? Some organizations might not have money, but they want very fast.
Whichever way you are going to have the speed, but the problem is, will you have redundancy? Because redundancy costs money.
Yes.
To have 2 ISPs, when one can take care of them, and they will be paying for the 2 ISP simultaneously. To have
most universities cannot afford that.
They go, you get the idea. To have 2 routers, one can just serve you. They will rather tell you that when the router spoil, tell us we'll buy another one. When the switch spoil, tell us that we'll buy another one. Than to give you money to buy two of this in order to have to create redundancy on the network. They will rather tell you when they spoil, let us know, we'll give you money for that. But if we want to be professional, we are supposed to be able to build this kind of network for them. But reality, it doesn't work that way. That's the truth.
Yes.
It doesn't
Okay,
work that
thank you.
in the real world. As a matter of
Mm.
fact, you discover that some people use plug and play switches just to get the contract. Because if you go and put a Cisco switch and I put a plug and play, we will achieve the same result. But in the long run, the client don't even know the difference between the two. Is it working? It's working. That's all they want to hear. Can we browse? We are browsing. Is it fast? It's fast. So what's the problem? Even if
Yeah.
I don't know about VLAN to enhance the security of your network, I don't know about curtailing broadcast and all of those things. They don't care as long as they can browse and it's very fast. Nobody cares. So they will give you the
Yeah.
contract. You can do it, yes. Are you sure you can do it with the same amount of money? Yes, I can do it. It will work well. And you will defend it. And then you will do
Yeah.
this. And then it will work. But there's something they are not saying. They don't see beyond it's working. We can browse, it's
Yes.
fast. That's all.
That's right.
So that's the reality of the environment we live in. They don't care about the professionalism or doing the right thing. How much can you do this thing? And we don't have money. They will tell you it's not covering the budget. Or we don't have enough budget for this. But when they do their own things, they can have budget for it too. But once if it has to do with IT stuff, there's no the budget is not going to be enough.
It's expensive.
And
Yeah.
it's everywhere.
Yes.
Okay, so if we don't have question again, so I'm going to continue. So now let's look at another. So you can see simple designs. Look at one here. Look at what they did here. Drop one switch here in one building, and then they have connection to each of the buildings. And these are all layer 3 switches. But this particular one at the center here will be of much more capacity than the other ones in the buildings. And this one will serve multiple switches in this place. This one too will serve multiple switches in this place. All you need to do is just inject internet connection to this switch, and all the locations have internet connection. But as we have it right now, there's no redundancy. No redundancy. But in some environment, you don't need multiple layer 3 switches. Just one multi-layer switch is okay to each of the location. Maybe they don't have more than 40 users each of the location, and that will solve the problem. So if you take a look at this particular design, there's another design we have in this place now. Role of switch networks. So we can see this design again here. Networks Networks have fundamentally changed from a flat network of hub to a switch LAN in a hierarchical network. A switch LAN allows additional flexibility, traffic management, and quality of service security. A switch LAN may also support wireless networking and other technologies such as IP telephone and mobility services. So this is what they are basically talking about. So this is access layer, this is our distribution, and of course this is our call layer. Again, it depends on what we want to do. It depends on what we want to do and what we want to achieve. So that is that for now. So we are going to be rushing right now. So the takeaway from this first part of this class is that design for JAM is all obtainable almost everywhere. And why I say that is because most of the networks you have around, they are not big networks. Most of the time you have organization with 50 staffs, 100. Before you get an organization that will have 200, 300, 400, 500, 1,000, you are talking of maybe universities. So we must be able to give them a design that will work perfectly. So having said that, the remaining thing I will just be flying. So scalable network. How do we design a scalable network? We must have redundancy. And of course, redundancy costs money. And for you to have redundancy, you must have multiple connections. You must have scalable routing protocols. What kind of routing protocol are you running? Your routing protocol must be scalable, meaning it will be able to grow, add more routers, add more switches, whatever you want to do. There's no disruption of your base configuration or your base design. And there must be wireless connectivity. And of course, wireless is taking over like crazy, especially with Wi-Fi 6. So if you want to build any network that is scalable, and don't forget we said, what is scalability? Is a term for a network that can grow without losing what? Availability and reliability. It has the ability to grow, and people are not going to know that you are doing something on the network. That means it's scalable. But if you have to shut down the network before you can do something, then the network is not scalable. So you must develop a strategies to make sure the network is available and it can scale easily and effectively. And these are the things you can put in. You must be able to accomplish it. So that is all. So how do you plan for redundancy? Of course, you said redundancy costs money. One of the things that has to do where you need to implement redundancy, we talk about spanning tree. Where you are supposed to have one connection between two switches, you get two. Where you're supposed to drop one switch, you can drop two. It depends on what you want to do. Look at this design we have in this place right now. They have two switches, two switches everywhere. And look at the connection, direct, and the way they cross there. So for you to have what do you call it? Redundancy, switch layer 2 redundancy, you must have this kind of design. Why? Because we want to create room for alternate paths. And I demonstrated that one with this spanning tree. One cable goes down, the other one will pick up. This one comes back, this one will take up. And if you like, you can bundle the two together to achieve load balancing. That is one way of planning for redundancy. And of course, don't forget your HSRP. We also did that, which has to do with layer 3 redundancy. It's another base of planning for redundancy. Okay. So what is the design you reduce failure domain size? What is the meaning of that? This is one of the reasons why you do segmentation. You create VLANs. Put people in VLAN 10, 20, 30, 40, 50, 60. If there's a problem with people in VLAN 10, it does not affect people in VLAN 20. If there's a problem for people in VLAN 20, it does not affect for people in VLAN 30, and so on and so forth. So sometimes the reason why we put people on different segments is not because they belong to different departments, it's because we want to reduce the domain, the failure domain, or we want to reduce the broadcast domain. Sometimes not just because of security, it's just for optimal performance so that we can have a good performance on the network. And we can do this with our routers, and we can do this with our multi-layer switches. How? You can use the router to segment the network. You can use your regular switch to segment the network based on department, based on function, or based on buildings, so that they can act independently of the others. Just make sure you reduce the failure domain, the domain of your failure. What I mean by that, that's why if you're asking me the question now, should you buy a 48 port switch to network 40 people, or you buy two 24 port switch, 24, 24, and then link them to, I will go for this. Because if you bought this, and if anything should happen to this switch, if it should die, you've knocked off 48 people on your network, or 40 people. But if you have two, the possibility of the two switches dying at the same time is very rare. It's zero. So what have we done? We have reduced the failure domain here. We've reduced the size of the failure domain as against having just one device that can go down and all the 48 people are gone. So you find a way to make sure you reduce the domain, the failure domain. Another thing is you should increase your bandwidth, and we have done Ether channel. Ether channel can increase the bandwidth on our network. If you realize you are beginning to have bottleneck and you don't want to change your switch or switches to go and get the one with higher bandwidth, you can bundle links together. If two cables is not enough, if two cables are not enough to be bundled together, you go for four. If four cables are not enough, four links are not enough, you go for six. You go for eight. I think the maximum is eight. You keep on increasing the bandwidth. And at the same time, when you want to buy a switch, for instance, you don't go for a switch of, let's say, 100 Mbps, even if the client say it's enough for us, that speed is enough. We don't even need up to that one. You need to factor in the future. If the client is requesting for, you think they need a speed of 100 meg, is enough for them on that network, you go for a device of 1 gig, 1 gigabit per second. Because tomorrow when they start growing, you don't have to come and tell them, yank off everything and begin to buy another thing on the network. So increase your bandwidth, put devices that have enough bandwidth. And if for any reason you cannot have devices with enough bandwidth, at that point in time, bundle links together, do link aggregation to increase the bandwidth. And sometimes the reason why we bundle links together is not because we want to increase the bandwidth, it's because we also want to create room for redundancy. Instead of allowing Spanning Tree to block one of the link and be using one, Spanning Tree will be using the two. It will be load balancing between the two. You use this link now and then use this link later. If any for any reason one of the link goes down, the other one is still working. So we have been able to achieve two things. We increase the bandwidth and we also achieve redundancy, and that also can be done with Ether channel. You can expand the access layer, and the easiest way to expand the access layer is to add access point. So if for instance I bought a switch of 24 ports and already I have, say, 24 people are connected on the switch, I don't have any port again, and now I have 10 users, new 10 users that want to connect. Instead of going to buy another switch, I can just remove one person from that particular one of the ports, connect my access point, configure the access point to take care of the users. There are access point that can support 50 users without stress. There are access point that can support 100 users. I think there's one that can even support over 1,000 users without stress. So what have we done? We've used the access point to increase access to the network. So we have some people on wireless, we have some people on wire. And most of the time, you don't just have one access point on your network. You have access points scattered all around on the network, depending on the size of your network. So you must be sure that the access point is secure, configure security, strong password. Make sure there is no interference. We've done access point configuration, and we've talked about wireless before. They must be on different channel, and of course the coverage should be good enough. You shouldn't have blind spots. It doesn't matter where I am, I should be able to access the wireless network. So when you're implementing the wireless network, you need to know who are the people connecting. Are they tablet? Are they laptop? Are they this? You just need to be aware of what is happening on your network. And then the last part is on this side is tuning the routing protocols. So if I'm running OSPF on the network, do I need to customize this OSPF to work the way I want it to work? If there's a need to customize, you customize. And what I mean by customize is you tune some configuration to suit your need. Look at this design now. Multiple routers. They put some routers in area 1, some in area 0, some in area 51. So what have they done? They've segmented the network at layer 3 with routing protocols by putting different routers in different areas. And with that, if there's any problem in area 0, area 51 don't know that. I mean, area 1, area 51 don't know that there's a problem in area 1, and so on and so forth. So you must be able to use all the things we have taught you to make your network work properly. And you may want redundancy on the network to also. OSPF supports more equal link. It can load balance between two different links, but I have the same speed. So that is that on that one. Any question, please, before I move on? Any
Hello,
question?
Sir. Hello, sir.
Yeah, please go ahead.
Sorry, this bandwidth always confuse me anytime you mention the bandwidth.
Yeah, let's talk about it.
Huh?
Let's talk about it. What is it that you always confuse you?
When you say that you always size bandwidth, so
I didn't hear you.
okay, when you say you increase the bandwidth, So I always look at it as this bandwidth. Can we refer it to a device, or how will I put it? So that is what I'm going to ask you, but you always escape my
Let me explain it to you.
yes, sir.
Let me explain it to you. And okay, I'm coming. Yeah, I need a clean place to explain this. So now let me explain this to you. Let's
Yes,
assume
sir.
we have two laptops and they are directly connected. You want to send data between these two laptops. When I say you want to send data, maybe somebody want to copy from the other side. Maybe laptop A want to copy from laptop B, or B want to copy from laptop A. Huh? At what
Yes, sir.
speed will they copy? Will one laptop copy from the other? What determines the speed? You know what is? Do you know the definition of bandwidth?
Yes,
Do you know the definition of bandwidth, right?
yes, sir. But it's just that they understand they have not yet gotten.
Yeah. So I want to give you the understanding now. So what determines the rate at which they will transmit that data? So if computer A now has to copy something from computer B, and this is the connection between them, at what speed will that thing be copied to computer A to be going to A? At what speed? What determines the speed? This computer has a network card. So most of the time you hear us say something like Ethernet.
Yes, sir.
Sometimes you hear us say fast Ethernet. Sometimes you hear us say gigabit Ethernet. What does that mean? When we say Ethernet, we are referring to 10 Mbps. When we say fast Ethernet, we are referring to 100 Mbps. And when we say gigabit Ethernet, we are referring to 1000 Mbps. What is 10 Mbps? You know what is 10 Mbps?
Huh?
Do you know what is 10 Mbps?
Yes, sir.
What does that mean?
Megabyte per second.
Eh?
Megabyte per second, sir.
10 Mbps.
Megabyte, huh?
Yes.
Per second.
That is 10 millions of bits. Eh? So if the network card on this computer, if it is Ethernet, that means the speed of that card is 10 Mbps. And let's assume this guy too is 10 Mbps. And as long as this cable can support that speed, it means the rate at which this guy will copy something from this other guy is going to be 10 millions of bits in 1 second. So if this guy has something of 1 gigabyte to copy, you will know how long it will take this other PCA to copy the thing from this other computer. That is the bandwidth, the speed.
Okay.
Are you flowing with me? Hello, Stevie, can you mute yourself?
Okay, sir.
Are you flowing with me? Who is asking a question, please? Who asked the question? Hello?
No question, sir. Go ahead, sir.
Okay, I said who asked the question? I want to talk to the person directly.
It's Arigbabu, sir.
Okay, good. So now,
Yeah.
that is one. What if there is a switch in between?
No, my own question was, I said I need a clarification between redundancy and
Okay, I'll come to that. I'll come to that. I want to finish with this bandwidth. Who asked the question on bandwidth?
It's me, sir. It's Steven, sir.
Okay, Stevie. So are you flowing with me? So what if there's a switch in between these computers? The switch also has its own speed. That's why you see some switches, the port on the switch, you see them, they will write Ethernet or fast Ethernet or gigabit Ethernet. That is telling you about the speed of those ports, the rate at which they can transmit data. And that is the bandwidth of the switch. So if your card supports 1000 100 Mbps, that is the speed, the bandwidth of your card, the rate at which it can transmit data. So if I now have this switch, now let's say this switch can transmit at the rate of 100 Mbps. That means this is fast Ethernet. And if my laptop also has 100 Mbps, it means the bandwidth of this network right now is 100 Mbps. So the rate at which these computers can communicate, they talk at the rate of 100 megabit per second. That is the bandwidth of the network. So if I now have two switches linked together, let's say I have two switches linked together, and the connection between the two switches is 100 Mbps, and I realize that it's not enough for me, and I had another cable, 100 per 100 will give me, is supposed to give me 200 Mbps. I have increased the connection between these two switches, or increased the bandwidth between the two switches, the rate at which the two switches can send data through to themselves. And bandwidth in the context of local area network is different from bandwidth in the context of wide area network. Why did I say so? If I want to connect to the service provider, what do I need to negotiate? They will tell me, what speed do you want? Do you want 2 meg Mbps, or you want 4, or you want 8, or you want 10? It depends on this speed. That is the bandwidth they will give you. That is the rate at which all your users can go to the internet. They will share that speed. And anybody that can chop one or the other will get faster connection if you are not doing quality of service. So in the context of local area network, your devices, the network card on the switch, on the laptop, they determine the speed, the connection, the rate at which data can be transferred end to end on the network. But in the context of wide area network, you pay your service provider to give you a particular speed at which you can access the internet connection. I don't know if is it clear?
Yes, sir.
Stephen, it's clear.
I get the understanding, now, sir. Very good.
Okay. So can I move on? Okay, so for the person that has the question about scalability and redundancy, scalability is ability to grow, meaning you can have more devices, you can extend the network without stress. You are extending, and there will still be availability on the network. You are not scattering everything to extend the network. Mr. Adedako, can you please mute yourself? A redundancy is you are creating a backup link, backup connection. In case one link goes down, the other one will automatically take up or is there, so that there will be no loss of connectivity. That is the redundancy. It's like a backup. You have 2 cars now, or 3 cars. One, you don't need more than 2 cars maximum, one for you, one for your wife. But you can decide to go and buy the third one in case any of your cars break down. You can carry the third one and use it. That is redundancy. Redundancy doesn't mean it's useless. It simply means a backup. Mr. Aribabu, I don't know if that's clear to you too.
Thank you, sir.
Is it clear?
Yeah. Thank you, sir.
So can we continue, please? Any other question? Please, can you mute yourself if you are not talking, if you are not asking questions? Mute yourself, please. What is giving us headache here? All right, let's move on if we don't have questions. Okay. Now we want to talk about the hardware. Now, why do we need to talk about hardware? This part I'm not going to stay long. When we talk about access layer, distribution layer, core layer, you need to know the kind of devices to put at each of these layers. So if I'm building my network, if it is 3-tier, which layer, what are the equipment that I can put at the core? What kind of equipment can I put at the distribution, and which one can I put at the access layer? That is what this one is all about. So you know this model of routers, so I can use them here. This model of switches, I can use them here. This model of layer 3 switches, so I can use them here, and so on and so forth. So you need to be familiar with the products. So it's not good enough to just know how to deploy these things. You need to be familiar with the products you are working with. So look at them here. So who is that again now? Oh, wow.
Yeah, Mr. Mubarak, can you please mute yourself?
You see, Mr. Mubarak that is disturbing us there. I'm trying to look for the person that is disturbing us there. Okay, so let's continue, please. So let's talk about switch platform. There is a variety of switch platform, form factors, that's the way they are built, and other features that must be considered before choosing a switch. It's not just good enough for you to go to market and say, "Can I get switch there?" Yes, we have switch. Bring me one. No. When designing a network, it is important to select the proper hardware to meet the current network requirement, as well as to allow for network growth. Within an enterprise network, both switches and routers play a critical role in network communication. So you need to understand that. If the client is telling you they just have 20 users, plan for 30 or 40. If you are not afraid, you will lose the contract. So Cisco LAN, campus LAN switches. Now, these are the model that Cisco recommend for us to use at our access layer, such as 3850 series. Look at the 3850 series here. They support high concentration of users connections with speed and security appropriate from the enterprise network. So I now have an idea that at least the least I can use at my access layer is 3850 series. In those days, I think we used to use a 2900 series, 2800 series, but now those ones have gone. Cisco came out with new stuffs. So you need to understand this. So if I am going to work and I want to use this switch now, what will I do with this switch? I will go and research this switch. What's the CPU capacity? What is the RAM capacity? What is the numbers of ports? Do they have varieties of 3850 series? All kinds of the details I need about this switch, I will go and check them out. Because I know I am going to be working with this switch or will be recommending it to a client. So I need to know about the product. Look at another one here. This one is Cisco Meraki. It's a cloud-based switch. And look at other set of switches here. Look at them like steps. This is one here. This is one here. This is one. Look at this big one here. Look at another. This one are called Nexus. Cisco Nexus platforms switches. These are used for service provider majorly. Or data center rather. I think the service providers will be still at the front. So it depends on where we want to use these devices. Look at another one where these are the ones used for service provider. And their models are not even mentioned here in this class. But you can research them if you need them. So if I want to build a data center, I need to know the type of switch to use. If I'm just using the switch as the access layer switch, I need to know the type of switch to use. So I need to get familiar with those devices. I need to be familiar with the products based on what I want to do. Because if you go and buy a car with 4-cylinder and give the car, expect the car to perform like the car with V6 engine, you are going to kill that car before it's time. So you need to know what is good for what you want to do or what you want to achieve. And all of this comes by research, experience, and so on and so forth. I don't even know some of these switches. I don't know them. I don't know them. I've never seen them. I've never read about them. But if for any reason I want to recommend for anybody, I just know that I need to check out which one is for data center, which one is for service provider, which one is for access layer, and I will see them plenty and I'll do my research, and from there I'll be able to recommend. So you need to know the switches, you need to know these devices. So what about the form factors? When selecting switches, network administrator must determine the switch form factors. These include fixed configuration, modular configuration, stackable or not stackable. So what is the meaning of all of these things? There are some switches that are called fixed, meaning what? Once you buy the switch, all the ports there, those are the ones you can get. But there are some that are called modular. Even if you have, let's say, 24 ports, you can add more chassis that will give you more ports. You can increase more ports on the switch. And there are some that are called stackable. I can combine two switches together and make it to look like one switch, or 4 switches together and they become one switch. And if it is not stackable, meaning I cannot combine them together. So it depends on what you want to do. That is what will determine what you go for. Do you want fixed? You want modular? You want stackable? You know what's not stackable? You need to understand. But you need to know that the options that are available, that are out there for you. So from the options, you can decide on which one to go for. Please, if you have questions, you can stop me. Look at an example of a stackable switch here. Multiple switches connected together with these cables, and they will function as just one switch. It will be like one switch. Work like just one switch, and there are multiple switches. You are not going to see something like switch A, switch B. You will see just one switch. Those ones are called stackable. Look at another thing you need to consider: port density. How many ports do you need on the switch? So too many things to consider. You need 12, you need 24, you need 48, or you need more than that. Look at this one with 384 ports. I think we used to have this one. I think that one not packed now. One switch, 384 ports. Mainly one building. This can take care of one building that has maybe like 200 users. I don't need multiple switches. I can just drop one there, and that will solve my problem. But at the same time, you know that you can create a single point of failure. So you consider, you go front, you go left, you go front, you go left, go front, you go left. You consider front and back. Weigh the options and see what is good for you. So another thing you need to consider, the forwarding rate. At what rate would that device function? That is the switch you want to buy. You care for 100 Mbps, or you care for 1 gig, or you care for 10 gig. You need to think about all of this. That's why you do survey. You don't just drop devices on the network and say, I'm done. You do survey. It is based on your survey, you'll be able to determine, I need this, 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 and so on and so forth. You also factor in the speed. You factor in the CPU. You factor in the RAM. You factor in so many things about the device. Another thing you can consider, do you need power over Ethernet? What is power over Ethernet? I believe we all know what power over Ethernet is. But in case we don't, let me just explain it. You have a switch here, and you have access point here. Let's say this is our AP. You want to use this switch to power the access point. The same cable that is carrying data is also the one that is carrying power to the access point. To power this access point, you need a PoE switch. What is PoE switch? A switch that can carry power over Ethernet. It's carrying data already, we know that, but it also can carry power and send to the device and power our device. Do you need one? What are the things that we can power with this PoE switch? We can power phone, we can power AP, we can power camera. There's so many things that can be powered. As a matter of fact, I heard that in the future, even your laptop will be powered by the same network cable that you plug to the switch. The PoE technology is getting to that level right now. So you need to also factor in that. Do you need a PoE switch? So different things to consider before you make decision. Do you need a layer 3 switch? If you do, why do you want a layer 3 switch? because probably you may not need it. And if you don't need it, if the organization does not have the money, you may lose the contract. So you factor in so many things. And I've also talked about layer 3 switch before, which is also called a multi-layer switch. So different things to consider is summary, cost. That is why sometimes, I'm sorry to say, this is a Cisco class, we have to say it. You see sometimes people run away from Cisco devices and go and look for other vendors too that can do the same thing because of cost, port density, power, reliability, the speed of the ports, frame buffer, scalability. These are the things you consider before you make decision on the type of switch to buy. And almost the same thing applies to our router also. So let's just walk through this. What are the things you want on the router? Do you want to use it for a small organization, big organization? Do you need multiple links? Do you need redundancy? And so on and so forth. So for a branch router, what do they call a branch router? Let's say like all these banks now that have branches all over. You know that the minimum Cisco will recommend for a branch office is 4000 series ISR, integrated service router, 4000 series router. It is good for your branch office. So what are we going to put at the headquarters? We will go to see others too. So meaning what will be at the headquarters will be different from the routers that will be at the branches. Different routers for different capacity. Okay. Network edge router shown in the figure enable the network edge to deliver high performance, highly secure and reliable services that unite campus, data center, and branch network. Shown are Cisco Aggregation Service Router, ASR 9000 series router. This is what they are recommending for us to put at the headquarters, depending on the numbers of branches we have nationwide, all over the world. So you need to have a robust router at the headquarters because it's connected to multiple branches where you have different traffics coming in. So you don't just drop any router at the headquarters, just drop anyone at the branch. No, you must look for the one that can do the job for that particular location. What about service provider? Look at the one, they are only 6000 series. So when we are talking of service provider, they also have routers that are recommended for them also. And they have given us an example here. So if for any reason I know that I need to use one of these router, all I need to do is just to do research about that particular model, read about the router, read about the switch, and I know about it in detail. And of course, what about industrial routers where they use heavy machinery? They recommend this particular model, Cisco 1100 series. These are small routers, but they are powerful, and these are good for industrial environment. So you will not be able to carry the other one that is meant for a regular branch where they don't have heavy machinery that is going to gather dust and all kinds of weather wahala and go and put in the industrial area. No, this Cisco built robust router for those kind of environments. So you need to get to know your routers. You need to get to know your devices. And we also have another one here, Cisco 900 series. And they say this is good for a small branch office. Okay, thank you. You see the numbers of ports we have here, just 6 ports. Maybe we don't have more than four people at that location, or at most maybe 20 or thereabout, just small office. And that doesn't mean that you cannot use it for some of the branches that most of these banks have, because most of the branches don't even have plenty staffs, maybe at most 20. But if you know that the branch is a big one, you cannot use the 100 series. You have to go for a bigger router to solve your problem. So these are different form factor, different design, different for different organization, for different environment, depending on what you want to use the router for. They have ASR 9000 series, 1000 series, and these are all routers that come with different designs, different capability, and so on and so forth. And here comes another one, 5500 series router. Is designed to scale for between the large distance center and the enterprise network, web, and service provider. So more of for service provider, look at the big router here. So even if you're going to work for service provider, you'll still be these routers there. different router for different environment. And this is another one here, Cisco 800 ISR router. And this is also designed for harsh environments. So different routers, different switches for different environment depending on what you want to do and what you want to achieve. So that's why you need to understand the capability of these routers and know what you want to do. Okay. Any question, please?
Hello, sir.
Yes, go ahead, sir.
Okay, actually, based on these form factors you've highlighted for both the switches and the what do you call it? iOS, or are there some things we need to learn differently from the iOS, based on these form factors? Hello? No.
Are you talking about the operating system in the routers and the switches?
I'm talking about these form factors. Does it, the iOS and the form factors, are they, like, if I'm using 4000 series, and I heard you mention about the 11,000 series, the configuration, the iOS version and all that, is it still going to be the same?
Well,
Or the form factors,
in
does
the
it?
past, what I know with like service provider, Cisco used to have the different iOS for them, for service provider. But now I think they have what they call unified iOS. Unified iOS is like, you just tell us what you want to do with this particular device, pay for the license, and you unlock it.
Yeah.
Everything is in the
Okay.
iOS. So, for instance,
Okay.
now if a service provider, now the model, the difference between the model most of the time is just in the hardware capability, not the OS.
Okay.
It's like you
Okay.
having Core i3, Core i5, Core i7. Now you can have Core i7 and I also have Core i7. But my Core i7 could be 32 gig with 32 gig RAM, 10th generation, and yours is also Core i7 and you have just 8 gig RAM. Maybe it's 4th generation, and probably I have SSD and you have the regular hard drive. You don't expect the performance to be the same, even though we both using Core i7. So Core i7 is different from Core i7. It's like Mercedes-Benz is different from Mercedes-Benz. If you see Mercedes-Benz 200, that is that long one, that old school, and see 300, say their papa no be the same.
Yeah.